Hello everyone, I'm going to do problem number 1 from the homework assignment from the handout given on verifying identities. Now what we want to try to do today is see if we can verify that cosecant x over cotangent x plus tangent x is equal to cosine x. Alright, so anytime we verify an identity, we want to make sure we have those general steps and procedures in our heads. Okay. What we want to do is we want to make sure we work from the left-hand side and leading to the right-hand side. So we have to have a start and we have to lead to the finish line. Now, the rule of thumb is to change everything that you see into terms of sine and cosine. Sine and cosine, those are the basic of all the trig functions. All right, so now let's kind of lead ourselves down the road here. Okay, so we're going to start off with cosecant x over cotangent x plus tangent x. That's going to be equal to, well, cosecant x is the same as 1 over sine x. And then cotangent x is the same as cosine x over sine x. Plus tangent x is the same as sine x over cosine x. So there's our first step in the problem. All right. Now we have a bunch of fractions. What we want to do if we have fractions within a fraction, we want to make sure we set up a common denominator. All right. So in this case, the common denominator here would be sine x cosine x. And then here, when we set up our numerators, that's going to be cosine squared x plus sine squared x. Now the top will remain the same. That would be 1 over sine x. Now, of course, we know this basic identity here, cosine squared x plus sine squared x, that's equal to 1. So in our next step is going to be 1 over sine x cosine x, and then on top will still be 1 over sine x. So now what's going to happen is that our fraction within a fraction, anytime we divide by a fraction, is the same as multiplying by its reciprocal. So what we're going to do is we're going to do 1 over sine x times, well, the reciprocal of this, we just flip it, sine x times cosine x over 1. And then as you can see, sine of x on the bottom cancels with sine x on the top. Therefore, we have cosine x. And we got to our destination.